Simply put, a gauge is a device used to make measurements and display information. In this case, we're talking about pressure gauges, which record pressure information within a hose or a pipeline. Most gauges work by an analog process in which physical objects within the gauge expand and contract, which actually turns the needle on the outside of the dial. For the types of gauges that we are talking about, they all use what is called a board-on tube. Now, a board-on tube is basically a small, C-shaped, hollowed-out metal cylinder which allows the fluid to flow inside. Once the fluid is inside the tube, it's time for physics to do its thing. Have you ever turned on your garden hose and watched as it went wildly out of control, like a snake rising from the ground? Well, the same process is what's happening inside the board-on tube, except the metal there is much more controlled in its movement. The pressure builds up on the inside and makes the small tube want to straighten out to balance out the forces. This change in straightness of the tube gets transferred to a set of gears and linkages, which actually turns the dial on the outside of the gauge. All of Winter's gauges are calibrated so that the change in bend of the board-on tube translates to an accurate measurement on the gauge. You can find out how accurate the gauge is by looking at its datasheet. The American Society of Mechanical Engineers rates the gauges on a scale of D being the worst to 4A being the best. You'll notice that all accuracies are given in percentages, and they will usually show 3 numbers. What this is saying is that the gauge has a slightly different accuracy depending on where the needle is at on the dial. When the needle is in the middle portion of the gauge, it is actually more accurate. For example, if a gauge has an accuracy of plus or minus 323%, this means that during the first quarter of the dial, it's accurate to within about 3%. In the middle half of the dial, it's accurate to within 2%, and in the last quarter, it's accurate to within 3%, giving this gauge a B rating. As nice as these accuracy readings are to have, there are still some other factors that can change the ability of a gauge to read properly. The biggest of these is vibrations. This is why there are 2 main types of pressure gauges: dry gauges and fluid-filled gauges. A fluid-filled gauge, like the name suggests, has a specially formulated fluid inside the gauge that acts as a dampener to vibrations. The board-on tube, linkages, and other parts are suspended inside this fluid. These liquids are usually substances like silicone or glycerin that help reduce vibrations, but can also extend the temperature range in which the device is usable. A dry gauge, on the other hand, has no internal fluid. Therefore, if heavy vibrations are present, the small parts in the gauge will rattle back and forth, causing a less accurate reading as well as a much lower life expectancy. A dry gauge will also not work properly in as wide of a range of temperatures as a liquid-filled gauge. First, how much pressure is the gauge going to be measuring? This is easily the most important question you have to ask before you make a selection. We'll start with a few definitions. First is gauge pressure. Gauge pressure is basically the pressure inside the gauge compared to the pressure of standard atmosphere. This is the reading you will take from the gauge in normal use. Proof pressure is the maximum pressure that can be applied to the board-on tube without rupturing it or causing a leak. The device will still be in proper calibration even if exposed to this pressure. For this 200 psi gauge, we might be able to handle a pressure spike of up to 250 psi, and the device would still be working properly when the pressure returns to normal. Finally, we have burst pressure. Burst pressure is the maximum pressure that can be applied before the board-on tube bursts or is seriously deformed. The gauge will require repair or replacement if this happens. For smaller gauges, this burst pressure may be high, even up to 10 times the amount of the gauge. But when you get up to higher PSI gauges, the device won't be able to withstand pressure very far past the maximum reading on the gauge. When selecting a gauge, It is always best to pick one where the approximate pressure will be read in the middle portion of the dial. This will provide the best accuracy and will give you some headroom in case there is a pressure spike. So, let's say you know that there will be about 500 psi in your pipeline. It is wise to get a gauge that will be rated up to 1000 psi. Next, you have to consider what type of fluid the device will be in contact with. Is it corrosive, water, oil, air? These will affect what type of materials the inside parts are made out of. The most common board-on tubes are typically made of stainless steel, brass, or Monel. It is important to check the corrosion charts beforehand to make sure that these materials will be suitable for both the internal parts as well as the NPT connection. Which leads us to another selection point. How will the gauge mount onto the actual system? Gauges come in a variety of different mounting options. Bottom, center back, lower back, just to name a few. Make sure to select the gauge that has the appropriate NPT fitting and orientation for your needs. Finally, we have a few more things to consider. The diameter of the gauge is important because it gives you a better visual readout of the pressure that you're looking at. A bigger gauge means you can stand further away and record that information. Then, there's the question of whether you need a standard gauge or a compound gauge. Now, a standard gauge starts at 0 pressure and moves the needle up to a higher pressure. A compound gauge has the ability to display both negative and positive pressure. So, that's pretty much all you need to know about pressure gauges and how they work. So let's go over some of the specific styles that we carry here at Gregg's. To start off, we have the Economy series. These are the most economical, all-purpose gauges we carry from Winters. They are all constructed with a black steel case, as well as brass internals and NPT connection. These dry gauges have a 323 accuracy and are usually used for plumbing, heating, air conditioning, and with various compressors. They come available in 2 styles, the PEM series, which comes in both a bottom and a back mounting option, with gauge diameters ranging from 1.5 inch all the way up to 4 inches, as well as pressures ranging from 15 psi all the way up to 5,000. The other style is the PEU series, which is designed for systems that require panel mounting. As you can see here, it has these back access points for mounting into a panel. The next series of dry gauges we carry from Winters is the Contractor series. This PCT style features a stainless steel case with a brass connection and has a 1% accuracy rating across its entire range. They are available in both standard and compound gauges and are mainly used for commercial air, water, and steam services. Moving up into the liquid-filled gauges, we have 4 separate series, all of which use stainless steel cases as well as stainless steel connections and internal parts. These liquid-filled gauges are much better for systems with heavy vibrations and highly corrosive chemicals. An important model to point out is the PN2 style that we carry, which meets the National Association for Corrosion Engineers standard for working with sour gas. Finally, we have our process gauges. These gauges provide the best accuracy and safety. They all have a 0.5% accuracy rating across the entire range and feature a heavy-duty thermoplastic case with a blowout back. With stainless steel internals as well as connections, these are great for working with highly corrosive materials as they are mainly used in chemical and petroleum industries. The large 4.5-inch gauge face is easily readable and they come available up to 10,000 psi. One last thing to note about Winters gauges is that they all come with an excellent 5-year manufacturer warranty.